luckily, it's time for the shameless plug. We just released malware score for macros into VirusTotal. I feel comfortable doing a shameless plug because this has been the last 6 months of my life. I was the primary developer on it. And this is a machine learning based maliciousness detector that looks at the macro text of a document. And actually, SpeedGrapher's original purpose was finding true positives for this, so we could improve the score here. So go check that out when you get a chance. But we're going to use that as the ground truth of labels. So next, we're going to build a dumb classifier. And I'm going to say it's a dumb classifier because in our operation, we haven't really built a classifier for this. I built this for this talk. We're still in the process of refining more information we can get for SpeedGrapher, extending it to different file types, all that sort of stuff. So we haven't really gotten to the classifier thing. But I want to show you how when you have rich data, really good data, and decent labels, then you can build something very robust very easily. And so what we're going to do is just take all that data that you saw in that JSON blob, just smash it into a vector. We're not going to do any analysis on it, anything like that. We're just going to put the raw numbers in there. So we take the color centroids, put those in there. We take the blur and blank vectors, we put those in there. The YOLO keys, we rip out the percentage and set them in the appropriate index level, put them in there, and we grab some text keys, drop them in there. This is one hot encoded. If it's there, the value is 1. If it's not, the value is 0. So if you had just enable content in text, you would have a vector of 1, 0, 0 because it didn't have enable macros and it didn't have macros. If you had enable macros in the text, then you'd have 0, 1, 1 because it had enable macros, and also macros because it had enable macros. So we have that, and we just put them all in a vector. I don't care. So one thing you do want to care about, though, later we're going to be using a random forest classifier, so this doesn't really matter. That's a quirk of the classifier. It's tree-based, decision boundary-based classifier. But in general, good data hygiene to always do is to normalize your vector between 0 and 1. You want to make sure that just because one of your features has a large scale, 0 to 9,000 maybe, you don't want that to overweigh another feature that's scaled 0 to 5 just because it has big numbers. It might not have big importance. So we're going to normalize this real quick. Convert it to NumPy vectors. If you don't use NumPy and you're doing data science, you're probably doing something wrong. So use that. And then we're going to build a classifier. And for this, we're just going to make a basic random forest classifier. This I just copy and pasted from Sublime Text, so this is more complicated than it needs to be because this could be one line. You just import import like random forest classifier from Ensemble, and then say number of estimators and max depth, and you're pretty much good. You have a classifier that you can train now. And then finally, we want to train it. One important part of training, and this should be hit home all the time, is you don't test on the data you train with. This would be like if you were getting ready to come to Vegas and you were practicing blackjack, and you look at your cards, and then you look at the dealer's cards real quick, and then you make your bet. That might work at home. You're going to do great at home. You come here, you get kicked out of the casino. Here, you want to train on a certain set of data and test on another set of data. But you want to be able to do this like at scale. So what we do is what's called k-fold cross-validation. And this is training on a portion of the data, testing on another portion of the data, and repeating with a different train and test set. So for this instance, we're going to do, say we do 10-fold cross-validation. We're going to run this 10 times. We're going to take a test set size of 10% of the data. We're going to train on 90%, evaluate on the 10%, record all the predictions that we made on it, and the valid scores, the true positive scores or the true scores of that. And then we're going to repeat that, but we're going to move our window, and we're going to test on the next 10% of the data and train on the rest of the 90%. And we keep on doing this and aggregate all of these testing points of information. And then we can create a confusion matrix. We can create false positive rates, true positive rates, all that sort of stuff. And we can create that ROC curve that we did before. So let's take a look at this. And again, you can plot in one line right there. You might even miss it because we're that good. We're up here. We have a receiver operating characteristic of 0.98, which was really good for a dumb classifier. That's a testament to good data going in. We can look at the false positive rate and the true positive rate. We have a sort of class imbalance of malicious versus benign in our training set. That's sort of okay. This isn't too bad. If you have like 100 benign samples and 20,000 malicious samples, you got a problem. This one I'd want to adjust, but for the sake of this, it's fine. And then we can look at our false positives. We have some samples that we label as malicious, but are actually, based on our labeling system, are considered benign. And we have false negatives, things that we label benign, that based on our labeling system, we label malicious. So it's always good practice to dive into those. You want to look at what you miss, and then you can tweak and adjust how you perform, change your algorithm, change your data, change your labels, and then retrain it and just minimize those two functions. So one thing that was very interesting is 70% of the false positives are actually neutered malware. So we see something like this. This is one of those samples, and you know, that looks very clean and all, but it is fishy. It's asking you to enable content to view a decrypted message. When you look at it in VirusTotal, you can see like the actual macro text, or if you have a parser that can rip it out or something, you'll see that macro code was removed by semantic disarm. Like, thanks, semantic. That's good and all, but you messed up my classifier. And also, the majority of the false negatives are malicious, but don't really show it. So we're doing a computer vision application. Some things aren't applicable for computer vision. This has to be part of a layered mechanism. You can't just depend on one thing. That's usually a tenet all the time. So some of these just don't look bad. Some are in characters that our OCR has trouble with. We didn't really do much configuration on the OCR. We could revisit this when we decide to, but a lot of Asian characters just don't show up for us. I think we were just using a Latin character set or something. And some don't show it on the first page. We have this nice resume by Joe Smith. Joe, if you're here, come talk to me after class. This is a security specialist, but if you dig into the macro there, that doesn't look like it's doing anything good. So while it looks like a normal resume, our computer vision application isn't going to detect it, because I wouldn't want it to detect that, because it doesn't look like it's bad. We're trying to find stuff that looks bad. Luckily, our other malware score caught this one, so we're all good. And so that's basically it. We're at about 40 minutes right now. We covered the background, if phishing's a problem, current strategies. We talked about Blazar and SpeedGrapher. And here's a set of links if you want to take a picture of. If you got any questions, I think we've got a microphone that we can pass around. And yeah, that's about it.
Well, thanks a lot, Daniel. So if there are any questions? Yeah.
Your ROC score was phenomenal, 0.98. It almost makes me a little skeptical. So what did you do to defend against overfitting?
Yeah, so overfitting is definitely a problem. For this, since we're using cross-validation, that's a decent measurement technique against overfitting. There is, and I will say there's an intrinsic problem with this data. There are repeats throughout. And so we might be training on something that looks super similar to something we're testing on. That's a huge caveat, and it's a very good point. This is something that we want to try to, when we are going to build a real classifier for this, we want to sanitize and deduplicate all of this. But that being said, a ROC curve of over 9.8 in this realm is not unheard of. Our macro detector is over 9.9. It's almost at 4 nines. We're trying to get that fourth 9.
Any more questions?
Yeah. So on the Blazor project, did you guys try to use different font types Because I can see how different font types would change the look of the URL.
That is a very good question. We didn't, that's sort of on extended research if we want to really develop this into part of the product. We used Arial as the font base, and with the repo, we asked you just to download Arial and install that one, because that's what it's worked on. But yeah, using different fonts, it should be trivial just to add a different font and expand your data set, duplicate your data set based on that. You might lose some accuracy, but it should work the exact same way. But this was a research project that we did. We haven't put this in the product yet, so we just used one font for this one. But that is a very good question.
For your Blazor, let's say you're trying to visit goggle.com, like you actually want to go to goggle.com, but is there any way to really make sure that it won't detect or try to train it so it won't flag legitimate but similar looking websites to like Google?
Yeah, so that's a very good problem. One way that you want to do this is expand your training data set to include things that are similar. You're never going to get this method to work 100%. I'll say it right there. We also use this for file name detection. If you're running a bunch of processes, we had like SVC host. If you replace O with 0, that's malicious. But you have stuff like Java and Java C. Those look like they should be spoofs of each other, but they're both legitimate processes. So when you have small character strings like that, you do have a lower rate. And you'll notice that our false positive, if you let me go back all the way here, let's see. Our ROC curve sort of bottoms out at one point, and this is exactly the problem that we're seeing there. 1 second. Yeah, you can see at the top we're not getting we're getting pretty close, but it does bottom out a little bit. We have, when we're doing the one for file type, it's even more pronounced. This one's a little bit hard to see, but file type, it sort of starts here and then jumps up, because you're having those characters that are legitimate but look like spoofs of each other. So that might be a whitelisting feature that you add to that. Like, okay, you can allow Goggle, it's fine. Yeah.
Any more questions? Well, that's grand. So thanks a lot, Daniel.
Thank you all.
So thanks for coming. This talk is about detecting social engineering attacks using natural language processing techniques. So we process the sentences and see if they're suspicious as they come in. That's basically what we're going to do. But I just want to first acknowledge my co-authors. So you can see toward the end of this list is me and then Marcel, who's standing right here. But the first people there who did all the coding are my students from last year. So they need credit for this because they actually coded basically the bulk of this, although they're not here giving the talk.
Yeah, so some introductions. This is Ian. So he's a professor in computer science at the University of California in Irvine, and he does research in hardware verification and security, and a lot of natural language processing stuff.
And this is Marcel Carlson. He's principal consultant at LootCore. He does red teaming, consulting, security research in general, and he likes to do hardware hacking, and social engineering is his favorite thing.
Yeah. Yeah, that's some fun stuff we did with some card terminals back in the day. Yes, so quickly, we'll do a little primer on social engineering. I'm sure you guys have heard of it, but we'll just quickly go through. So we have a definition here that's pretty good. So what's social engineering? You can sort of explain that as any act that may influence a person to take any action that may be in their best interest or not, right? Because remember, not all social engineering is evil. You might have a doctor or something who will actually social engineer you into doing something that's good for you, even though you might not know that's the case. So again, social engineering is nothing new. It's been around for a very long time. You have con women, con artists, men, and your kids are very good social engineers. If they want ice cream or something, they know how to do that. Very good. It's a very fascinating but also complex topic. We don't have time to go into all the details, but you have things like body language, microexpressions, framing, pretexting, elicitation, and stuff like that, right? So there's a lot of things that goes into social engineering. If you have more questions, we can talk about that afterwards, but we don't have time to go into details about that. Let's talk a bit about organizations and companies, right? They're really, I would say, exposed to social engineering. Because if you think about modern business or organization, it's a complex ecosystem of technology, people, processes, and of course humans working together. And usually, I would say the sort of threat, the social engineering threat is usually underestimated by most companies, and the awareness is usually quite low. I would say it's sort of become better the last few years. Some companies do some pen testing with spear phishing and stuff like that, but normally it's pretty bad. So if you do any sort of spear phishing and social engineering attacks, it will usually work, and that's why it's still being used today in most sort of attacks, right? And another contributing factors, of course, if you think about sort of solutions in a company, even business processes, often there's a burden on the individual user to take sort of security decisions, right? And that will be, of course, exploited by social engineers. And that leads us to sort of trust relationships. If you think about your typical organization, they will, of course, engage service providers, trusted business partners, and often you will have someone running your physical security, like facility management and stuff like that. And of course, this will expose a lot of trust relationships that, again, a social engineer will target, attack, and exploit. And to identify these sort of trust relationships, our social engineers will use, of course, open source intelligence gathering. So most companies and their employees will post all kinds of information on social media platforms. So what we can do is harvest all this information, including metadata, and we automate that so we can harvest a lot of stuff quickly. And of course, there's data dumps, data leaks out there with passwords, usernames, so you can find out the user sort of format and stuff like that when we need to do our phishing. And all the sort of technology infrastructure information like IP addresses, all the sort of stuff. We'll gather all that information to build up processes and profiles of companies and people that we will use for our attacks. And there's some pretty cool new tools that are coming out. If you look at sort of the topics at this conference and Black Hat and stuff, you'll see a lot of machine learning, cognitive science stuff. And this is something called Microsoft Video Indexer. and it's free. You can just sign up, and then you can actually upload videos, right? Here's the fake Obama video from BuzzFeed. You upload that, and we'll do some pretty cool analysis. So we'll extract metadata. So we'll actually do facial recognition and find all the people in the video against the timeline. It will do transcript of all the sort of spoken words and extract keywords. And you can see here, we'll even translate the different languages. We'll do OCR to take out stuff that's being text that's sort of in the video, and pretty cool stuff, right? So we can see it's moving in the sort of direction that we can even use video now to extract metadata for our sort of profiling. Quick word about the methodology. Like we talked about trust relationships, it's all about gaining trust. We will extract information, influence the target, keep doing that a couple of rounds, and then eventually we'll have a compromise. And talking about sort of social engineering attacks, right? It's nice to blend social engineering attacks, so you can do it remotely via sort of email, messaging, SMS, voice, these sort of remote attack vectors, or locally, where you sort of show up in person. And then you can, of course, mix and match these sort of things. And attackers are lazy, and they like to work effectively. So, of course, path of least resistance. Basic stuff works, and you don't really need 0 days to do this sort of attacks. Here's an example of a typical phishing email. This was from the DNC attack. There's a guy called Podesta, John Podesta, right? So someone phished him pretty good. They used some basic sort of obfuscation to bypass the filtering in the email solution, and sort of hiding the target or the URL there when you click on change passwords. You can see here, this shouldn't work, right? But it works every time, pretty much. Like, people don't pay attention. You can see here, it's not a secure URL. It's actually .tk domain, as you can see there, so you shouldn't really click on that, but people do usually. Here they've used his own sort of picture from his Google Plus page to make it look nice, so he would actually put his credentials in there and be phished. As you can see, it's not very sophisticated stuff, but this actually works. That's the scary thing, right? So talking about what's coming more soon here, there's something called deepfakes. I'm not sure you guys are familiar with this. So you can take a video now and use some pretty basic tools on your laptop and take, for instance, a set of videos or pictures. So you can put, if you take a porno video, put some celebrity's face on there, or maybe your girlfriend that you didn't like. That's actually moving really fast in terms of the development.
Doesn't have to be porno. It could be.
Yeah, it doesn't have to be, but I'm saying it's always porno that sort of drives the evolution, right? So that's kind of funny that that's where it's sort of starting always.
True.
But I'm saying we will see this, for social engineering attacks as well, because then, of course, you can alter video, like the Obama video. You can put someone else's face on a video, and that's pretty scary stuff. Which brings us to stuff like adversarial games, right? It's a concept where you have sort of two counterparts. One will produce sort of fake stuff and sort of submit it to someone who will judge whether it's real or not. Here, this example is sort of dollar bills. And it's sort of cat and mouse game. So of course the faker will become better to sort of trick the investigator who will look at this sort of fake stuff. And the investigator will learn how to spot the fakes. And if we introduce machine learning and sort of AI into the mix, we have something called generative adversarial networks, or GANs. So this is sort of the same idea, but here we introduce something called backpropagation. So again, we have a generator sort of creating fake sort of content based on training samples, submitting it to a discriminator that will sort of look at it to see whether it's real or not, comparing it to real samples. And then sort of the determination data will actually be sort of fed back to the discriminator and the generator to actually become better. So that eventually the generator will actually produce content that the discriminator will not be able to tell whether it's a fake or not. And that's actually interesting from a social engineering perspective, because you could do this to sort of audio. So if you have a bunch of audio snippets, we can actually create a model where we generate sort of fake audio that will be very close to the real thing. And again, there's research being done in this area, but it's moving pretty fast, right? So it's a very interesting area for social engineers to look into. And yeah, so it's looking pretty bad, right? A lot of exposure, a lot of attacks, it's working nice. So what can we do to sort of defend ourselves?
Thank you. So I'll start talking about the tool. So what it is that yellow box right there, it says social engineering detection. That's what we provide. So it takes text that some potential attacker has spoken, and it analyzes the text to see if it is suspicious or not, right? And if it is, then it reports it back. So you could connect it to an email client or a texting app or something like that pretty easily, you know, because it's already in text form. Or you could do it, if you had speech to text, you could use any audio video device. You could put it on a phone, right? If you did speech to text first, then just feed it the text, and then it would output some kind of alert message. Of course, you know, right now all it's going to do is print text to the screen, scam detected or something like that, but you could easily put any kind of warning. And so yeah, we're analyzing each one of these sentences as spoken or sent. And this is one that, just to differentiate this from a lot of previous work in social engineering stuff, most of it is phishing, just phishing emails, you know? But what about if you do it in person? What about if you do it over the phone, right? Then you only have the content to look at. You don't have metadata and, you know, URLs and all this. And so this is what we're talking about is effective against, as long as you have content, doesn't matter what form, you know, what the vector was. You could use our approach. Okay, so the basic idea is that in order to detect a social engineering attack, social engineering attacks are complicated, but somewhere in that attack, the attacker has to ask some inappropriate question, so meaning asking a question whose answer is private, right? Like, you know, what's your security, social security, whatever. Or they got to give you an inappropriate command, tell you to do something you shouldn't do, like click on the link or something, right? So we're assuming that somewhere in the social engineering attack, they got to do one of these two things, right? So I'll call it the punchline, okay? At the end of their maybe they're warming you up, flattering you, whatever, make you feel good, but at the end, they got to be like, okay, what's your social security number, right? They have to do one of these two things. So ask a question or issue a command that's inappropriate. So that's what we're trying to detect. So now what I'm going to do is, so I have a demo. We have a demo, right? In case that fails, I have a little mini video of a demo right now that we'll run through, and I'll just sort of talk through it.
Last night, actually. So.
Yeah, it worked 5 minutes ago, but, you know, like 10 minutes ago. Okay, so let me start this guy. Yeah, so basically I'm going to start running it. So basically all I'm going to do is just type in sentences, and it'll tell me if it's a scam or not, okay? So it is slowly starting. Okay, now I'm going to start running it. Okay, it's called temp. My students named it. They're lame, but don't worry about that. Okay, enter a sentence. So you got to type a sentence in. So I'm just going to enter some random sentence. Nice weather we're having, right? And it's going to say, that's fine. So hit enter. It's going to say, first one takes a long time. It's usually quicker. Normal sentence. So I'll highlight that. So okay, so that worked, right? So now I'm going to type in something that's more suspicious. I forget what it is. Oh yeah, a command. Give me money, okay? So that's suspicious if somebody's like, give me money. So that we detect, scam detected. Now notice give and money, right? We find the verb and the direct object, and that's sort of the idea with the commands, right? The verb, direct object, that pair is suspicious. Now we're not just searching for words, the words give and money. We look at how they're used in a sentence. So here this is, give me a poodle for money. Now that's a silly sentence, but I bring it up because it's innocent and it has give and money in it, okay? But this thing, we will not detect as being malicious because we can see that give and money are not used. So give and poodle is a direct object. So this is an innocent sentence. So just because it has the word give in it, the word money in it, doesn't mean it's malicious. So we're not just looking for words, we're looking for how they're used in the sentence. Then I get some questions. Yeah, so those two are commands. These are questions. So what is your password? That's clearly bad. Oop, I spelled it wrong. So that's clearly bad. So hit enter, and it's going to tell me, it detects it as a question, and in a second, it's going to say, scam detected, okay. So then if you can ask it some question whose answer is not malicious or is not suspicious, and it won't detect it. So what is your age? Okay, so I didn't consider that to be suspicious. So I didn't put that, we have a database of answers which are suspicious, and that's not in there. And so it says it's a normal sentence. So that's basically what it's going to, if I have time, I should have time, I'll show a longer version of that demo, but that's basically what it's going to do. Okay, so system structure. Now this is big, and I'm not even going to talk about the whole thing, but the idea is it starts with text that's spoken by some attacker, and in the end it gives you malicious sentences over on the right, meaning sentences that look suspicious. And if there's more than one, like say you're scanning an email, and there's a sentence, one or more sentences that look suspicious, then we say this is a phishing email, or if you're talking and one of the sentences that this person says is malicious, then we say, okay, they're scamming you, warning, you know. So the main thing I'm going to talk about over here is, okay, so first thing we have the sentence processing. We put periods in the sentence. So people don't necessarily use proper punctuation, right? So we have to put that in automatically sometimes. But say you got these sentences, we got to determine, is it a question or is it a command, right? And maybe it's neither, in which case we ignore it. But if it's a question or command, then if it's a command, we do command analysis to see if it's a malicious command. If it's a question, we do question analysis to see if it's a malicious question, private question. So these are the things I'm going to talk about, like how we do those things. Like tell if it's a question or command, and then once we know it's a question or command, how do we analyze questions? How do we analyze commands? So, okay. So detecting. So how do you tell if it's a question or command? So this and a bunch of the things we do are based on parsing. Okay, so we take the sentence and we use a syntactic parser to basically, which tells you the grammatical structure of the sentence. The parts of speech for each word, noun phrase, verb phrase, all that stuff that you forgot in 6th grade, which I forgot. I have to learn again. There are parsers that automatically do this, and we use the Stanford parser. It's a popular one, and it works really well. So it gives you a parse tree of the sentence that shows you the different parts of speech. And we look at the parse tree to look at the structure of the sentence, and we basically find patterns in there that we think are suspicious. So here's an example. Here's a sentence, can I eat? Okay, that's this parse tree over there. And these, just to say what these tags are, S is for sentence, noun phrase, verb, modal. Anyway, it's a bunch of tags. And you get a tree like this, it shows you the internal structure of the sentence. Now this is a question, and notice, say I compare can I eat to I can eat. The way we made it a question, like one way to make questions in English is you swap the subject and the modal, right? So can I instead of I can. Actually, same in French and a bunch of other languages. But that's one way you can detect the question. So if you see, actually the parser does this for us. This SINV tag, that stands for subject invert. If you see it in the sentence, you know that this is a yes-no question where they inverted the subject and the modal. Okay? So this is given to us for free. We just get the parse tree using another tool. We say, oh, is that SINV tag in there? Yes, it's a question. And also SQ tag, because there are other types of questions. This is a closed question, a yes-no. There are also open questions. What is this? What is that, right? And we can detect those with, actually there's a series there's some slides I left out just because there's a lot of detail in it. But I have a white paper that I'll be happy to give anybody who wants to read it. But it gives all the detail. But there are a bunch of tags we look for, and we can say, look, if we see these tags inside there, we know it's a question. So then, once we know it's a question, we do command detection. Sorry, change that around. Question, if we know it's a question, so we do, I said that wrong. We have to check if it's a question, and we have to check if it's a command. If it's not a question, then we got to check if it's a command. So the way we check if it's a command, there are several different ways to write commands. A common way is just to have a verb without a subject in front of it. Okay, so so go home, right? I didn't say he goes home. I said go home. Just no subject to the left of it. Stop right there. You just put the verb right in the front, right? And there's no subject in the sentence at all. So if you see a sentence like that with no no noun phrase to the left of it, then you say, okay, that's a command. That's one type of command. It's a common type. Then there are other ones like more polite ones. So often you'll say, please go home, right? Especially social engineers often do that. They want to soften it. They don't want to seem like an order, so they say it in a nicer way. Another thing they do is suggest, you could go home. You should go home, right? It would be good if you went home, right? These type of soft suggestions, we detect those too. Could, should, they're modal verbs. And we look for a pattern in the tree where you see like a you, then a modal verb, and then the sentence, the verb and the rest of the sentence. And then we can say that's a command too. So there are several different types of commands that we detect by looking at patterns in the parse tree. So we can detect if it's a question or detect if it's a command. Now, once we know if it's a question or command, then we got to analyze the question or command to see if it's malicious. So with the question analysis, how we analyze a question, basically the idea is to determine if the answer to the question is private. Okay? So if it's private, the answer is private, then sound an alarm. If it's not private, then no problem, right? So if you say, where's the bathroom? The answer is not private, so no problem. But you say, what is your social security number? The answer is private, so you sound an alarm, right? So we wanted to tell if the answer to the question is private. I'm not going too fast, am I? No, okay, cool. So we want to tell if it's private. So what do? We basically use research and question answering systems. So question answering research it's an active area of research. A lot of people do. There's a lot of industrial work in it too, where the goal is you ask it a question, it gives you an answer. And it either looks through a massive database of facts to find the answer, or it looks through the internet itself to find the answer, okay? So it's like what Google does, except better. It understands the question well enough to be able to find the answer, okay? And I don't develop question answering tools, but they exist, okay? They're pretty bad, okay? Because it's a hard, not that bad, but it's a hard problem, okay? Taking a natural language question and providing an answer is really hard, okay? So when I say they're bad, they have a low, they're not correct most of the time, okay? But that's okay, you know, they're starting the field and so on. But like for instance, the tool that we're using, it's correct 44% of the time on their test examples, on their test questions, which is low, right? But we modify it so that it's good for us, okay? Because we, well, I'll say in a second though. But anyway, so you look through some massive database and find the answer. Okay, so we're using the type where you're looking through a massive database, and the idea is you take a question in English, you got to generate a query. So say I'm using a SQL database, right? And I make some query. And then I use a query to search the database, and I find the answer. Okay, that's how question answering tool. That's how a lot of question answering tools work. So what we do is we basically say, one change that we do to an existing question answering tool is we say, look, instead of having this database of like 15 million facts, we only put in the private facts. Okay, only the private facts. Then, if you find it in there, you know it's private and it's a malicious question. If you don't find it, then it's innocent. Because see, we don't need the answer to the question, right? All we need to know is it private or not, right? So instead of 15 million facts, we'll have like 100 facts that are the private facts. You know, whatever facts you want in there. And we'll put them in the database. We actually put the fact too, I should mention. We put the information about the fact, but not the fact itself. So say I said President Obama's age was private, right? So I put it in there, put his private tag, and I wouldn't put the age in there. Because somebody noticed me, that would be stupid if you just have a database full of private facts if somebody got, you know. So, but we don't need the actual fact, right? We just need to be able to say, if you did a query search on it, it would find this entry. And then that's enough, right? We don't need the actual fact. We just say, look, we found it in there. It means it's private. So, okay, so the question answering system we use is called Paralex. Here's their reference, their paper reference. And it's open source, and we just downloaded it and used it. And this is sort of 3 entries out of their table. So they have a massive SQL table of like over 15 million things that they culled from Wikipedia automatically. And it's got basically everything's a triple, a relation and 2 arguments. So official language of Hong Kong, Cantonese, plural for bacteria is bacterium, and so on. Okay, so they got this massive database of facts. And okay, so that's what they have. And what they do is they take the English question like this, they generate a query, and then they search the database to find the answer, right? And they're correct 44% of the time. You had a question?
Can you go back to this?
Go back? Oh, it's too fast, huh? Yeah. Oh, okay. Oh, yeah, just want to see it. Okay, yeah, sure. If you want any more information, I'm happy to give you the whole paper, like any time. Like after this, I'll just, if you have a thumb drive. Anyway, so this is the idea. So and we didn't do this, they do this, right? They make the query. Now, one thing is, since this problem of question answering is really hard, is they don't make one query, okay? They take the English and they make multiple queries. In fact, like 30, 40 queries. Because it's basically guessing at what the right query is. It doesn't know what the right query is. So it tries lots of different possibilities. So it doesn't generate one query, it generates like 30, 40. Okay, for one question. Then it ranks them, and they have a ranking algorithm, and then the one at the top of the ranking is the one they use. And then they search. And if they find the right answer, if they find the answer in there, that's what they give. Now, this is example, actually, this is an actual example using their tool, where it comes up with these 2 queries. It comes up with a lot more, but I'm only showing the top 2. The top 1 query, its answer is Steve Jobs, because it's misunderstanding the question, right? The second one is actually giving the date, is giving the right answer. So for this question, they answer it incorrectly. Because they come up with all these queries, they choose the top one, but their ranking was messed up, and they got the wrong one. But note that the answer, usually the correct query is somewhere in the top group of queries, but they're only choosing the one top, okay? So we change that, okay? So one thing we do is, like I said, we strip the database down to just the private facts, like information about all the private facts, okay? The other thing is that we use the top 15 queries. Okay, so we don't just take like the top 1 query, find the answer. We take the top 15 queries, search them all in the database, and if the answer is found in there, then we say it is private. Now, what that'll do is it'll increase the rate of true positives, right? Because if the right query is the 2nd or 3rd rank, we'll find it. So we end up getting correct 99% of the time. Okay, but it may increase the rate of false positives. Because maybe maybe this thing isn't actually private, but one of the other 14 are it has an answer which is private, and that's possible, but extremely rare. Okay, because remember we have there's a database of facts in the world. It's like actually this tool uses like 15 million facts. We have like 100 private ones. The odds that if you pull 15 random facts out of there, that they're actually just accidentally in the private set is really slim, because you're talking like 100 out of like 15 million. So the chance that it increases false positives is really slim. So that hardly ever happens. Okay? So even though we look for all 15, the other 14 are probably not going to be private, because they're just sort of randomly spread out across the database. So that's what we do with question answering. Yeah, that's basically how we analyze a question. Okay, so in addition to analyzing questions, we have to analyze the commands too, which, by the way, are much more plentiful. Like in the data that we were looking at, you see a lot more malicious commands, like click this link or whatever, rather than malicious questions. Now, this doesn't mean that, if you do it, we're using phishing emails. In person, I would expect a different answer, but I would expect something different. But anyway, command analysis. So the idea here is, if you get a command that's just telling you to do something innocent, fine, it's no problem. But if they're telling you to do something, please tell me your social security number, right? You shouldn't do that. Then it should set off an alarm, right? So how do we distinguish which commands are suspicious and which are not? So we basically summarize the meaning of the command as the verb and direct object, and its direct object in the sentence. Okay. So, and then we basically have a blacklist of those verb direct object pairs. So for instance, take a left at the corner. Take is a verb, left is the direct object. Please give me your password. Give is a verb, password is a direct object. Okay? So we take the sentence, the command, find the verb direct object pair, and then we basically have a blacklist of bad verb direct object pairs. If somebody says give password, that is bad. Right? And we flag, that's basically what we do. We look it up in the blacklist, and if we see it in there, then we say it's bad. Now, there's other stuff that I'm not going to talk about, but for instance, synonyms, right? We handle synonyms. My little demo version doesn't, but the real version handles synonyms. It does lemmatization. So for instance, this verb might be in a different tense, gave or something like that, right? So it normalizes to find like one lemma for every word. Plural versus singular for nouns, right? It normalizes all that. So, but right now I'm not really going to talk about that. And when I say we did that, again, this is all built into Stanford Parser, right? They have tools for that already built in. So we had this topic blacklist. When I say topic, I mean verb direct object pair, and and you have to make that, and you just look up, see if the verb direct objects are in there. So, how do we find the verb direct object in a sentence? So we parse a sentence, and again, we're using Stanford Parser. They have a type dependency parser, okay? And that thing is very cool, actually. It tells you basically the semantic roles of the words in the sentence, okay? So specifically of interest to us is DOBJ. So it says, like, if I said, please give me your password, it would in this parse, it would tell us DOBJ, direct object, give password. Tells me that, right? So I know give is a verb, password is a direct object. And this is given to us. Stanford Type Dependency Parser already provides that. I didn't even write that, okay? There's another way to find a direct object too, but there are two tags, DOBJ and another one, end subject pass for passive sentences. But either way, it gives you the verb direct object. So that's how we find the verb and direct object of the sentence that we take in. And then we just look it up in the blacklist. Now, this blacklist, it's basically verb direct objects, right? Now, these pairs, you could compile them manually, okay? You could just manually, in fact, this is a good idea. We're going to explore that actually next week when I get back. But you can make it manually, but what we did was we have like a pile, we have like 187,000 phishing emails we got from various sources. We took 100,000 of these phishing emails, and we looked at the verb direct object pairs in there. And basically what we wanted was verb direct object pairs that occur in phishing emails and don't occur in non-phishing emails, right? So to do that, we took 100,000 phishing emails, 100,000 Enron emails, which are our non-phishing emails, and we basically computed this term frequency, inverse document frequency. This was mentioned in the last talk too. It's a metric that's used to basically, if it appears in the one set a lot and not in the other set, then this gives a high value. Okay, so if you see it a lot in phishing, not in the non-phishing, then it gets highly ranked. Okay, so we did that. And we got, basically we just had some cutoff, relatively arbitrary cutoff point, and everything above that we said, okay, that's our blacklist, okay? That's what we did. There are a lot of cases where that's not the best thing to do. Like you would want to do this manually. You can do it manually too. Okay, so anyway, we got the topic blacklist. Demo. Okay, I got the demo early. Cool. Now let's see if it actually works. You saw the video though in case it fails. Okay, so it's a little hard to read, but this is a virtual machine instance, a Ubuntu virtual machine instance. So there's 4 windows in here. This is just my directories that I'm going to need later. Actually, I might not even need this open. This is where the action's going to go on. This is where I'm going to type in the sentence, and it's going to tell you if it's a scam or not. Down here, these 2 are related to the question answering. So this is the question answering tool. It has its own little server there, and it's running in that window. And then this guy is the parser, the Stanford Core NLP parser. And this guy talks to this guy. So when this guy needs a question, it needs to answer a question, it sends it to this guy, which parses it, and it sends the parse tree back, and this does analysis. So, but most of the action's going on over here. Okay, so let's try this. Let me go over here. Okay, let's ask something innocent. Just make a sentence. Hello there. Okay, so that's not anything, right? And it says, okay, it says a normal sentence. Fine. Okay. And direct object pair, it didn't find anything because it's not even a command, right? The commands are where we need that. So let's give it a command that's malicious. What's a good one? Now I'm blanking on my example I was going to use. Give me money. No, I don't think that's. I don't know if that was in there. See, basically, I have a limited blacklist. I'll show it to you in a second, okay? I got to use something out of the blacklist, so let me stick with my plan, right? But you could easily add that to the blacklist, but for this demo, I have like 8 pairs or something. Anyway, so let's say give me money. And it's slow, I don't know why, but it will quickly. Yeah, okay, that's right. Okay, scam detected. Yeah, good. Yeah. Now, if I say give me a car, it it should say normal sentence, okay? So notice it says, you know, oh, that might be bad too, but I can put it, no, but I can make it bad. Hold on. So give me money, it says, you know, give car. It said, okay, give car, that's not in my blacklist. So what I'm going to do is modify my blacklist, which I have open right here. This JSON file, this blacklist.json, that's it. So I will open it up.
So the point is to, of course, customize your blacklist, right? Depending on what's valuable to you. So you can put whatever you want there. So
yeah, that's exactly right. Like the idea is that if you were using this, you know, at your company, you would put in verb direct object pairs that are relevant to what you think people would want to get out of your employees. You know what I mean? So you would make it by hand. But here's a sample one that I got. And so you can see give money, give resume. Oh, I actually had send money in there. What do you know? Borrow money, whatever. So and there's all those O's. Ignore the O's. Those are options that we haven't really implemented yet. So let me put car in there, give car in there, okay? So I'll just add give car, and then I got to put the O's in there.
There's just options and this.
Yeah, like TF IDF is supposed to be in there. There's a bunch of things that we're going to put in there soon that are not there right now, but a bunch of numbers we're going to put in. But yeah, right now. Okay, so yeah, I think I put that in there. So let me save it. Okay, so now close up. Okay, now I'm going to quit the program and start it again so it reads that blacklist again. Now I should be able to say, give me a car. Me a car. It slowly will detect that it is a scam. Yes? Yeah, there it goes. Yeah, scam detected. Okay, so it's as easy as that. You can just add these verb direct object pairs in there to cater to your own needs. You know, question?
Could you do the same demo with the same pair, but a substantially more complicated sentence?
If it could, most of the time. And the car, so give car is car. Car would still have to be the direct object of give. Can you give me a sentence? I mean, I'm willing to try. It may fail.
I was given a car for my birthday.
Listen, you're a really cool guy. It'd be great if you could give me a car.
Well, but I'd like to see a different
that's
car.
malicious.
Give me some car. It'd be great if you gave me some cars.
But see, okay, so just so you know, this demo is fragile. Now, unlike the real thing, you said cars with an S, it will lose it just because of that.
But you said you were removing plurals.
In the real thing that is on the GitLab, but for the demo that we scraped together quick, it doesn't do it. Oh, I'm sorry, I think he was next, and then, I'm sorry, I think you were next. So.
I don't want to screw you over, but I used to work for a German company, and the Germans used to really hate speaking to English people because of the way the semantics in which we talk about. And I've written a few sentences down here, right? Would you by chance know are you able to tell me and I don't want to screw you over because this is really awesome and you're trying to squeeze this into a really, really short amount of time. And they're quite complicated sentences. So, just kind of following on from that.
This is gonna guaranteed to fail on this. I mean,
sorry, dude.
What was the first one? Just out of curiosity.
Would you by chance know the password associated with the account? It's
okay,
quite a
I'll say
sentence.
This demo will not do that, but the actual one would. So would you? That would, it'll detect that as a modal and it would catch it. But most of the ones you're going to say it won't. Okay. But let me go on. That's all right. You're next, and then you. So you go ahead.
Where?
Straight behind you. Straight behind you. Like way back. Like straight back there. Yep. No, yes, at the wall, back wall.
I didn't see you. You fell into the wall.
I'm a ghost. That's exactly how I am. Which is how I would like this next question to be treated if we can. Here is an example sentence from a real world case. I am in need of your company name API keys. Can you please provide?
I need your, let's see. It would say need and then keys. I mean, you said, could you please provide it? Okay, so one thing it doesn't handle right now is pronouns. Okay, so could you provide it? That could be caught if we handle pronouns. Now, pronominal resolution is called. That's like a known thing in natural language processing. I'm not doing it, but if I were doing it, it's like basically I wouldn't make it up. Like I could find an off-the-shelf technique and just apply it, but then it could handle that.
Yeah.
Is there an it at the end of the sentence, though?
Yeah.
Yeah.
Is it implied?
No, he said it.
Yeah.
Yeah.
Yeah. So the context there, actually, the word "it" wasn't even there.
Really?
Yeah. It was like, could you? It was, can you please provide?
Oh yeah.
Now,
then it wouldn't. Yeah. So
Yeah.
So when you start talking, so basically this is limited to one sentence at a time.
Right.
Basically, to understand that, you got to connect two sentences.
Yeah.
And we don't do that.
Could it simply handle the phrase "I am in need of API keys"?
Well, it would get need API keys.
Yeah.
And then if that was in your blacklist, then it would catch it.
Got it.
Yeah. Question?
First, I just want to say this is really cool, and I feel like the audience is collectively trying to figure out ways to break this, and I'm intending to add on to that
look,
pile
this
as
is
well.
good. And anyway, go ahead.
I can think of lots of really cool ways to use this, not just for detecting phishing, but also adding on to bad user behaviors. I'm thinking you take your chat feeds internally, through Slack or whatever, and you want to stop people from sharing their passwords with each other or sharing API keys with each other in a chat form like Slack. This would be a cool way to see employees behaving badly.
Yeah, there's all sorts of evil uses too, but I won't go into that. I'm why isn't the U.S. government already doing this? Which maybe they are. You know?
So my question, how are we handling, and not in the demo version, but in the real version, how are we handling real social engineering, targeted social engineering, in which we are creating a scenario that seems realistic, where I'm hey, I'm system admin, blah, 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 please update your password.
We catch that. Update password. I'd catch that for sure.
Update password?
Yeah, meaning the targeted aspect of it, see, one of the beauties of this is that all that complicated stuff that you do, the pretexting, elicitation, all that, it doesn't matter. We're not even looking at that. We're just looking at the punchline, the end where you're look, give me the data or do this.
So does this flag on things like actual security communications where they're hey, you guys need to update your passwords?
Yes, and I'll get so let me just, before I get to your question, basically the problem is this has no idea who is speaking. Okay, so it assumes this is a foreign person speaking. If your mother asks you for $100, you should give her the money, maybe. But if a random person asks you, then that's suspicious, right? So we would have to be able to identify the speaker, and that's part of what you're saying, and we can't do that. Meaning there are other techniques to do that type of thing that we will investigate. Yeah, you have to add it on top. Go ahead. You had a question right there in the blue.
just kind of similar to the last two questions, kind of a combination kind of thing. So, like, I know that you just recently just said that you only look at one sentence, and my question is kind of like, going back to kind of real life, if I was to social engineering someone, I would be like, hey, give me your password, or can you give me your password? Like, people would be suspicious. I'm not going to give you your password. So what if, like, say I bury the subject in the noun or on the object in multiple exchanges? Let's just say if I say, hey, what do you think is a secure password? And then that's the question, the first question. I was like, I don't know. Like symbols and stuff? And I was like, well, do you think yours is secure? How do you set yours? What is it? So
Okay, what is it, right? There's a punchline.
Right.
And if I could resolve that back to the now, which is easy, then I could detect that. What is your I could substitute the it for your password, and then I detect it.
Right. And that's an example, but like say if you were to keep this memory, and how do you, like say if you're just having a natural conversation, it would be fairly difficult to trace back what the it is, especially if you're talking about multiple subjects, right?
I disagree with that. So this problem of tracing back what the it is, they call it pronominal resolution, and natural language processing people have been trying to solve it for decades. You know what I'm saying? They do a pretty good job of it. I mean, I didn't implement one of their techniques, but so I don't think it's as hard as you're saying. I think people have looked at that problem a lot.
Is that like something that you guys are looking at like?
Yeah, I'm gonna add it. So I just got a nice fat grant to do this, and I'll be doing all that. You know. Go ahead.
Right, thank you.
Yep, sure.
In all fairness, though, I think what's kind of interesting is the simplicity of what you're talking about, which is to say, because as I understand what you're talking about here is a simple solution, that because it's simple, it's not baffled by all the pretexting that people are talking about. And complex, awkward sentences also have the problem that a real human being misunderstands it. And so that if a social engineer really, wants to know for sure that the password that they've just been given is in fact the password as opposed to something else, they have to ultimately be clear to the human being. And at the point of there being clarity, that's your punchline, and that's what you're triggering on.
And let me just say something to comment on that, right? So this guy, Chris Hadnaghi, you may know, he runs the social engineering village at DEF CON, right? So actually, I published with him earlier, talked about this a lot, right? And he wants to use this to train social engineers to be better, okay? He's like, yeah, you try things out, and if I detect it, then they got to reword it in a new way, so I miss it, right? And they could do that, right? And there can be this back and forth, just like malware detection, right? And then I can change this to be better, and they can change there to be better. But mine has a finite limit, meaning humans only you can't just write random English sentences. It's got to be something understandable by a human. You can't write arbitrarily complex, bizarro-sounding sentences. So there's like a limit to how much that can go on before I win and I can detect every way a human could express something. Or this is my claim anyway. Where with malware detection, that limit, I don't see it. You know what I mean? Question? Oh, yeah, I think, yeah. Okay, go ahead.
Okay.
Oh, sorry. He's after you. I'm sorry. You go ahead. You go ahead.
Okay. Okay.
Yep.
So as a social engineering, I work in Brazil, and security awareness there is very non-existent, actually.
Yeah, sure.
So actually, this works a lot there because most of users are really just way more stupid than we can possibly think.
Yeah.
So they handle passwords without you asking for it. It's like doing it's awesome. Doing a social engineering job there is like the easiest thing ever because the security guard gives you the password to the door. It's ridiculous. But this, and it's mostly not because people are stupid, but because they never had contact with awareness security programs and such. So this could be very helpful for stupid users per se, but because it generates an alarm, it gives you the alert that this phrase has password and give together, you should really think about that, you know, because you're kind of being stupid. So you should consider that.
Yeah, I'm not sure. I mean, I
so
think,
it helps bringing awareness more present to the days of everybody else who works with confidential confidential infos like passwords.
I think this problem is not only Brazil. I mean, I'm from Scandinavia. It's the same there. I mean, it's like you say, the awareness is so low.
The Nigerians heard about this.
Exactly. It's everywhere, you know, and yeah. So whatever we can do to sort of help the situation, right? So
yeah, he has to go next because we skipped him. Go ahead.
What if I just say, I would like to give you a car?
I would like to. I don't know. Let me try it real quick. Normal sentence. It didn't detect that. Yeah. Wait, he's next though, and then I got to go. Go ahead.
I'm back. All right. So one other tactic that I'll see as part of social engineering campaigns that I've run is I will genericize a question as much as I possibly can. And what I'd often see happen is I would feed some information that I know that makes it appear as if I have some insight into some secret. And then from there, I will ask a generic follow-up, which is, what other information do I need to know? Or just more blatantly, what else might I need to do X? Yeah. I might not even say to do whatever. I might just say, what else might I need? And then once I've confirmed something that might appear semi-secret but isn't really, that's the point at which the person, the mark, may start to vomit information right back at me because they feel there's some sort of established bond of trust. I feel like this isn't necessarily designed to speak to that, but I don't think that that's necessarily the point. If I'm understanding correctly, this is definitely intended to sift out the broad spammed phishing attempts, as well as some of the modestly more intelligent ones. I'm thinking that somebody that's exceedingly motivated or somebody that's on a particularly motivated whaling mission might still be able to pass this. Thoughts?
yeah, I mean, there's a lot of ways you can sort of bypass this. Remember, it's kind of a simple demo, right? Like you said, you can even say something on purpose incorrect, and they will, you know, say the correct thing back. Yeah, these sort of things, right? So this wasn't sort of designed to catch these sort of very sophisticated sort of examples, right? But yeah.
Yeah, like I know there's another question, but yeah, like for instance, like I got in one of these slides. Okay, so for instance, so along the lines of what you're saying, just we're detecting questions and commands. So just don't ask one, suggest it. So you could say, what is your password? Or you could say, I can reset your account, but I'll need the password first. You didn't ask a question, but they're going to give you the password, you know? So that's along the lines of what you're saying. That is more sophisticated than I can deal with. Because you have to understand the mental state of the person. I can't do that yet at all, you know? He's behind you, is quite right there.
So I just wanted to, so I also run an offensive security team of some sort, and I live in this world as well. And I just wanted to make a comment and kind of respond to what you're hitting on. I think the point here isn't that we've designed a perfect system to solve social engineering, right? It's that we now have perhaps a tool where, without this, what is our defense against this? It is relying on the human to catch the most basic dumb stuff. Someone going, give me your password, and them going, K. Like, that is not a solved problem right now. And we try to use awareness and things like that to push that up. But if we could technically solve it, which this does, we could at least raise the bar so that the dummies don't get our users' passwords, and they at least have to freaking try hard, right?
Yeah, that's
which is
right.
the idea of security.
Right.
Make them try harder, right? So, and I think this is a really cool thing. So.
Was there another question? Thank you.
So
yeah, right there.
We got another 5 minutes left.
That's fine. I don't have to finish the rest of the talk. This is all I had to get to the demo. The rest is just fringe stuff. Go ahead.
I'll be quick. So you had the slide that said, you input something and then you test it and then you get the result and then it goes back. So can we put this in that?
Oh, so it's not.
Portion?
So that I had that slide. It doesn't do that so much. Meaning, what I mean is, all we do is we do exactly what it shows, right? It takes text and it prints out text. But you could easily hook it up to, instead of printing out text, you could hook it up to a screen and put a warning in front of you on the screen, or put a message in your ear on a cell phone or something like that. But it doesn't do that. I haven't closed that loop. But that's sort of an easy thing to do, I think. Okay. So I'm going to go on. Okay, so basically, just to say, results. So we tried on a lot of phishing emails that we found from these different sites. And here are the results. Now, they're not that good, actually, but this is a starting place, right? So this column is for phishing emails, and this column is for Enron emails, okay? And this is how many we classified as detected as phishing, or as malicious, or not detected, okay? And what we want is 87,000. So we had like 187,000 mails of each type. 100 we used to train, so 87,000, right, is what you get left. So we would like it if all the phishing were detected, so this is 87,000, and all the Enrons were not, so this is 87,000. So these are bad, right? And they're non-zero, okay? So I'm going to try to explain some of them. Let's start with the false negatives. The phishing emails. So 35% of the phishing emails were not detected as phishing. So why did it fail so badly in that sense? So basically because what I did was I had the students look at 100 of these false negatives and manually figure out why they weren't detected. And what happened is, so basically we just detect this punchline, okay? The question or command. But in these phishing emails, a lot of these phishing emails in the data sets we looked at, they don't have that. They're just the start of, they just say, look, hit me back, okay? That's like the most suspicious thing they say. Now, so we don't catch them. Right, and that's like 35. That's not 35%. That's like 80%, 79% of the mails of the ones we didn't catch were just like that. In fact, like here's one. This is a subset of it, right? ... But in the end, it says, "Please, you can call us or reply us, whatever." Right? But we didn't catch that as being malicious. Now, I would argue that eventually, in this email conversation, they would have asked a question or made a command, and we would have caught it then. Okay, so I don't feel too badly about the fact that we missed all these false negatives, because I think it was just a bad data set, in my opinion. And I'll mention too on the side before I run out of time that, is there something you want to say? Okay, I'm talking a lot, but no, seriously. So one thing we're doing, so one problem that we've had with this work is people say, look, you're saying you can detect in-person attacks over the phone, but you don't try it out on any. You haven't evaluated on any. That's because they don't exist publicly, okay? You can find phishing email data sets, but you can't find conversations that are phishing, that are social engineering. So what we're doing with my wonderful grant that I just got is we're going to run an attack. You know Social Engineering Village, you know? So we're going to do that, right? I got it approved, where I'm going to pay students $15, and I say, look, in 3 months, sometime in 3 months, you're going to get an attack, right? We're going to call you up, try to scam you and we're going to tell them explicitly this data or whatever. But they're going to forget, right? And 2 months later, we'll call them. They will have no recollection of what I told them, and then they'll get fooled. And we're going to run a bunch of attacks and see, so we can get a data set. We can say, look, these attacks work and these don't, you know? So we're going to do that actually next quarter. Question?
I was going to just say maybe a better suggestion is call the elderly.
But
so, you just returned whatever you scanned them for. And that might be like real world.
I mean, oh, stop. I gotta stop. I'm sorry. But wait, can we have questions? When you say
we're running out of time, but I think you can squeeze one question in.
Okay, go ahead. No. You go ahead.
So, do you have any kind of concern that students these days don't actually get calls anymore? And so, just the inherent fact that you're calling them may already be suspicious?
So,
No,
I mean,
I think it's going to work.
Yeah, we're going to, people get calls.
Yes.
I mean, I don't think it's that bad.
No.
Kids today, you know, maybe, look, we're going to try it. I mean, look, what I got approved is what I said. We'll spoof the caller IDs, you know, and we'll make calls like that. Okay. I guess that's it now.
So since there's the last talk, let's take another 5 minutes of questions.
Okay, sure. Any questions? We might be done with. I mean, that's likely. Go ahead.
I'm curious if you've tried combining this with any kind of sentiment analysis and seen how that might play out.
I have not. So sentiment analysis. I looked at sentiment analysis. But for what I'm trying to do, I don't think I need it. It's because, sentiment is basically plus minus, as far as I understand. It's like good to bad, right? But some of these things, like give me money, is that good? Is that bad? You can't even classify it that way. So I don't see how it's useful for this. Yeah. Oh. Any other questions?
Any more?
That's it? Question? Okay, she's got a question right there.
Actually, it's not a question. It's more like a story that I have that you may consider. In Brazil, actually, calls are very common and are so common that people don't think twice on believing it. So things like, hey, you just want a car, give me your credit card number so I can credit to you. And they do give the credit card number.
Are you saying Brazil should be a target of our attack?
Yes. Yes,
okay.
I'm just giving you
Heard
this
that,
tip.
everybody?
You're going to be very successful.
All right.
And we need that.
Okay.
Very bad. Because months ago, my coworker came to me crying with money in her hand, like very desperate. Oh, Marina, the doctor just called me. My husband is in the hospital, and I need to pay for the transfer. And I'm like very desperate. Can you take me there? I have to take the money to the doctor. And I was like, what? Take the money to the doctor? What the fuck? Call the doctor. And she called the number that called her, and some guy answered it, and I'm like, who's talking? Oh, I was working with a guy and he got an accident and I'm in the hospital with him. The doctor is very desperate. They need to transfer him. And I'm like, okay, let me talk to the doctor, please. And then this other guy answered, and I was like, and I answered, how is the husband doing? What happened? And the guy answered me, he just have his leg is kind of hanging. It's very fucking bad. You're like, just give me the money.
Is it very fucking bad?
Yeah.
Fucking
but
awesome
in Portuguese, which was way worse than fucking.
Yeah. Okay.
I'm like, oh, okay, I see what's happening here. Yeah. But that was a good try, man. And that happens. It's not, it's going to work very good in Brazil.
Okay. Damn. Okay. So I guess we're done, right?
Yeah.
All right. Thanks for coming.
Thank you so much.